Hey guys, welcome back to our 3-a-day multiple choice marathon. If you have been with us through all 17 episodes so far, go ahead and let me know in the comments. Today, we are going to be doing episode 18. As we say, it's just three per day. We started the 2019 paper that was given in May 2019, right? And we are now going to be doing questions 52, 53, and 54, which means after this is just 2 more days and we are done. All right, so don't forget it's 3 o'clock every weekday. And then Saturday Night Live at 7 p.m. Don't miss it. Invite a friend, invite them for another week. So as we start 7 o'clock, everybody ready. All right, so here we go. Question 52, and it says, which of the following pairs of lines is perpendicular? Now, what do you know about lines if they're perpendicular? If this line looks like this, if this line looks like this, and I'm going to attempt to draw a line perpendicular to it, yeah, kind of ish, all right, forming 90 degrees right there, then it means one of them is sloped the total opposite way to which the other is. All right, so we know that if two lines are perpendicular, then their gradients, there's something special about their gradients. Their gradients, the product of their gradients will be -1, which means one gradient is the negative reciprocal of the other. So let's see what we are talking about. If the gradient of, let's say, line number one is 2/3, then the gradient of line number two, which is perpendicular to it, is going to be the negative. So you change the sign of what you had before. Negative reciprocal, that's going to be -3/2. We know that some people like to say flip when they talk about when they talk about reciprocating. So yeah, that's pretty much it. So if you have a line that has a gradient of, let's say, 1/3, then it simply means that we are going to have to reciprocate this. That's 3/1, which is 3, and negate it. So that means if this was already a positive gradient, then this is going to be negative. That would have been -3. The lines that have these two gradients would be perpendicular to each other. All right, so when two gradients are perpendicular, one is the negative reciprocal of the other. And I would have mentioned earlier that if you find their products times -3/2, if you find their products, then it's going to be equal to -1. 2 into 2 goes one time, 3 into 3 goes one time, -1/1. So we need to know which of these pair of lines actually have gradients that are going to prove that they are perpendicular to each other. All right, first of all, we know that the equation of a line looks like this: y equals mx plus c. That's the general form, which means if we try to get all our lines looking like that, then we should be able to get some hints. All right, this pair of lines is actually in that form already. And we know that the coefficient of x is what would be our gradient. So right here, 2 and 2, these lines are actually parallel. All right, so that's another bit of information for you. Parallel lines have the same gradients. Anyway, so we can rule out that one from now. All right, as I said, we're going to write these two equations in the form y equals mx plus c, which means we're going to attempt to get y by itself on one side. Everything else will work itself out. All right, so we have 2y equals -3x minus 8. And if we get rid of 2 here, it means we're dividing each term by 2. All right, and then we have y is equal to -3/2 times x minus 4. All right, so the gradient of the first line here is going to be -3/2. Remember, our gradient is what is right here beside x. All right, so we have that to be our gradient, and we are now going to look at the second equation. All right, if we have 3x minus 2y equals negative 8, and we're trying to solve for just y, we just want y to be on one side by itself. All right, that means we are going to, first of all, let's get rid of 3x here. If we subtract 3x from one side, do the same to the other side. So now we have negative 2y equals negative 8 minus 3x. Dividing both sides by negative 2, you can just do that to each term. We have y is equal to negative 4 minus 3 over 2x. What is the coefficient of x here? Negative 3 over 2. Actually, that is, those lines are all are parallel. So we move to C. Let's see how C works itself out. All right, so y is equal to negative 4x plus 10. And that already tells us that our gradient is negative 4, which means we can start thinking about it from now, the fact that if we are going to find a gradient, if we're going to find a line that is perpendicular to this one, the gradient must be the reverse, the reciprocal of 4 over 1, which is 1 over 4. And since that was previously negative, then we expect the next gradient to be positive. All right, so here we go. We take the next equation, which is 4y equals x plus 1. We want just y to be on one side by itself, so I divide everything by 4. All right, y equals x over 4, or a quarter x plus a quarter. There we have it. All right, so our gradient for this one is a quarter, and our gradient for this one would have been negative 4. They are negative reciprocals of each other. So there we have it. C would have been our answer. All right, you can pause and take notes. I'll be moving on. So we go to number 53, and it says, what transformation maps PQR onto P prime, Q prime, R prime? So what transformation maps this PQR to P prime, Q prime, R prime? And of course, it's not an enlargement. None of them not bigger than none. Of course, it's also not a rotation. All right. And it's also not a translation, as a translation is just, you can literally watch the image slide from one place to another, glide. All right. But of course, it looks like these two things are mirroring each other. And so, indeed, well, I was trying to get a straight line there. All right. So they are mirroring each other. Indeed, this is a reflection. All right. And so our answer would have been D. All right. So we will move to our final question for today. It says this is an isosceles triangle, and immediately you should start thinking, even before you finish reading the question, that, okay, what are the properties of an isosceles triangle? And you are already hinted as well that these two sides are equal. All right, which means these two angles that we call or base angles right now, they must be also be equal. So this angle is actually 30 degrees. And right now, it doesn't matter what they want to ask you next, I'm sure you can figure it out. All right, so it says in the triangle, what is the value of x? Now, x is a certain angle, of course. And we know that the angles inside a triangle should add up to 180 degrees. So we go x plus this 30 degrees here, plus this 30 degrees here, should actually add up to 180 degrees. All right, so we will just solve the equation. X plus 60 degrees equals 180 degrees. And I'm solving for x. I'm going to subtract 60. I'm going to subtract 60. and we end up with x is equal to 120 degrees. All right. So, of course, some persons could have done this without writing out an entire equation, and that's fine. If this were a paper two question, this is how you would want to show you're working. All right, that's it for today. That is the end of our 3 a day multiple choice segment for today. It's episode 18. So join me tomorrow. We're almost at the end for episode 19, where we'll do questions 55, 56, and 57. And as usual, see you on Saturday night.